Welcome back again. Let us try to solve some of the problems here on limits again. I hope the previous session was good. I've been getting response from that previous sessions saying that try to again they are looking forward for some more other problems. So let us see those problems here. Okay. Okay, let us say the limit as x tends to 0. Uh, Now you have sine x into sine inverse x divided by x square. Let us try to solve this. Now let us separate this. So this becomes a limit as x tends to 0, sine x by x, okay, and limit x tends to 0. This is sine inverse x divided by x. Now we know this result as 1. Now if I put x is equal to 0, this becomes 0 by 0, so which is indeterminate form. Now if I uh, differentiate and with respect to x for the numerator as well as for the denominator uh, by L'Hopital rule here, so this becomes limit. I get limit as x tends to 0. This would be differentiation of this would be 1 by square root of 1 minus x square, and this is 1. So this results 1. Okay. Let me try to solve another problem. Okay. Let us see those problems now. Okay. Now we have limit x tends to 0. This is a log of 1 plus x whole cube. This divided by sine cube x. Let us try to solve this here. Okay, so if I multiply and divide by x cube, if I multiply and divide by x cube, this, right? So x cube, if I keep it like that and keeping this denominator and trying to further simplify this and making much more easier, this would be sine x by x. Okay, this is whole cube. This is what I'm trying to put up. Okay, and the limit x tends to 0, limit x tends to 0, this will be a log of 1 plus x. Okay, x be x cube here. Okay, x cube. Okay, this again divides by x cube. Again, if I put x, this however is 1. So this, if I put x as 0, so I get 0 by 0. Okay, I hope you understood this. Now again, let us try to find the differentiation of this. The differentiation of x cube would be 3x square. Okay, and log x is 1 by x, 1 plus x cube, and this divides again with the 3x square. Okay, so the limit x tends to 0. This is x cube here. Or if I try to simplify it further, Uh, these two, this is x square. Okay, so 2 gets, this 2 gets answered. If I put x is equal to 0, so this becomes 1. Okay, I hope you understood this problem. Let me try to solve another problem here. Okay, okay. So for limit of x tends to 0, let me try to solve this. Now let me put tan uh, x minus x, and this is x square tan x square tan x. So now if I multiply and divide by x here, numerator as well as denominator, if I multiply and divide by x, if I multiply and divide by x here, so I get x cube in the denominator. Let me put that separate, and if I take only x term in the numerator. Further, if I simplify that as limit x tends to 0, so this is x by tan x, and this is limit x tends to 0. Uh, this would be tan x minus x divided by x cube. Now again, this results to 1. Okay, this results to 1 when you put x limit as x tends to 0. And this, if I put x is equal to 0, so this is 0 by 0. Now using L'Hopital rule here, so let us try to differentiate in the numerator and differentiate with respect to x for the denominator. So what do I get? I get secant square x minus 1. Okay, and this should be 3 x square as limit x tends to 0. Now if I put x is equal to 0, again I get 0 by 0 here again. Now differentiate with respect to x for the numerator. I get 2 secant square x and tan x. Here I will get 6x. Now limit x tends to 0. So this will be again 0 by 0. Now further, if I differentiate with respect to x, okay, uh, I get, this is limit x tends to 0. So this is 2 secant square x and tan square x, plus we have secant over 4x divided by, this will be 1. So when I put x is equal to 0, so I get 1 by 3, which is the final answer. Okay, let me continue the next. Let me take up another problem of limits here again and try to solve this. Now, if I have the limit which is x tending to 0, so let us find log x, and this is cot x. Okay, so let us try to solve this. Let us try to solve this here. Now, here if you look, so this leads to a minus infinity, and this also leads to infinity. So this is infinite by infinite. So let us see how to solve this now. Again, by using L'Hopital rule here, we can find the solution for this. Okay. Now, again, here differentiating with respect to x for the numerator, I get 1 by x. And for cot, I'll get minus cosecant square x. And this is limit x tends to 0. Fine. So this again I can simplify this again as this as, if I put that as sine square x and divide by x, and this is minus limit x tends to 0. Okay. Now again I'll multiply and divide by x here. Multiply and divide by x here. So I can put this sin x by x and limit x tends to 0. This is minus and this is whole square. And I'll have limit x tends to 0. I'll have x here alone. Now this result is minus 1, but this is 0. So I get 0 is the answer. Let me try to solve another problem. Okay. So if instead of log, and we'll just put sine here. Okay, instead of log x, I'll try to find sine x. Okay. Again, if I put this as 0, I'll get here as minus infinity by infinity. Okay. Infinity here. Again, it is an indeterminate form. Fine. Let me try to solve this here. Now, a log of this differentiation would be cot x, and cot is minus cosecant square x. Okay, so the limit as x tends to 0. Okay, now let us put as x tends to 0, again minus infinity by infinity. Okay. Now again differentiate this cot, I get minus cosecant square x, differentiating. And in the denominator I get 2 times that of cosecant square x and cot x. Okay, so this limit x tends to 0. So these two get cancelled. So I'll have only minus half and limit x tends to 0. 1 by cot is tan. Now when I put x is equal to 0, so this becomes 0. So this is the result of this. Fantastic. So I hope you understood how to solve these problems. Okay, let us look into the next problem here. Again, I have the limit as x tends to 0 here, or let me put pi by 2 here. Limit as x tends to pi by 2. This is a log of cos x. This is b divided by tan x. Let us try to solve this problem here. Now differentiation of this would be uh, minus tan x. Okay, and this is secant square x as limit x tends to pi by 2. Okay, again, of course, this is minus infinity and infinity. So again, minus infinity and infinity. Let us again differentiate with respect to x in the numerator as well as in the denominator by using L'Hopital rule here. So I get as minus secant square x divided by, this is 2 times secant square x and tan x. Limit x tends to pi by 2. So on the whole, when you cancel this out, so I'll be left with only minus half. Limit x tends to pi by 2. And this is cot x. Now this is again 0, so I get the result 0 as the result. Let me try to solve another problem. Okay, so let us see with respect to x. Okay, I'm taking the variable here. All on this problem, you find only x here. So limit as x tends to 0. Log, now this is tan x. Now the base is x here. Okay. Now, if you look at this, I can separate this as the limit x tends to 0, log tan x, the base e, and this is log x, the base e. Now this, when I put as 0, so I get infinity value, which is an indeterminate form. Again, by using L'Hopital rule here, so this differentiation of tan is secant, and this is 1 by tan. So secant square x divided by tan, and this is 1 by x, and limit x tends to 0. So further, if I try to manipulate this, so I get limit x tends to 0. I need only x and tan x here. Goes up and tan in the denominator into, this is limit x tends to 0. This is uh, secant square x. Now this results 1. Okay, this results 1. Now again, this also results 1. Okay, this also results 1. So I get 1 here. I hope you understood this problem. Let us try to solve uh, few more problems, which is quite interesting and which is very, very important. Okay. Now, what we have looked into These problems are 0 by 0, which is our of indeterminate form and so on, and minus infinity and infinity by infinity, again, which is of indeterminate form. Let us try to look into the form and try to evaluate of the form which is 0 multiplied with infinity, and if I have infinity minus infinity, and so on. So let us try to look into those kind of problems here, okay, and try to evaluate these kinds of problems, and it is quite interesting. Okay, again, let us see the limit as x tends to 0, x to the power of n have, and this is log x for n greater than 0, for n greater than 0. Now here, if you look at this, so when you put x is equal to 0, so this is 0, and for this it is minus infinity, which is again indeterminate form. Okay, so let us try to look further how to solve this. So if I put as this is log x and this is x to the power of minus n. Again, if you see this, again this is minus infinity and this is infinity. Okay, now let me try to solve this as limit x tends to 0, differentiation of this by using with respect to x by L'Hopital rule here. Okay, now this would be 1 by x here. This would be minus n x to the power of minus n minus 1 here. So if I try to simplify this further, x gets cancelled. So I have x to the power of n, and this would be again 0. So this is the solution for that. I hope you understood this. Let me try to solve another problem. Okay. I hope you understood this problem. So limit as x tends to infinity. This is e to the power of 1 by x and 1 into x. Now if you see here, 1 by infinity, which is 0 and 1. So uh, this is 0, this part is 0, so 0, and this is infinity, 0 into infinity. Again, this is of indeterminate form. Okay, let me again try to manipulate this. So this is 1 by x, and this is minus 1, and this is 1 by x. Now the limit as x tends to 0, infinity. So if I put here, this is in the denominator, you'll have infinity. Or if I take, let me take 1 by x as some variable t. Let me try to evaluate. So if x is infinite, okay, so t will be 0. I have changed the limits, okay, by changing the variable. So the limits would change as t tends to 0. And this would be a to the power of t and minus 1 by t. Okay, now if you notice this, this is 0 here in the numerator as well as 0. I have formed into this. Again, by using L'Hopital rule here, as limit t tends to 0, this is a power t, and this is log a. And differentiation of 1 is 0, and in the denominator I have only 1 here. Now if I put t as 0, okay, since the log a is constant, so t as 0, so a to the power of 0, which is 1, so I'll get only log a. So this will be the solution for this. Okay, let me try to solve another problem here. Now, if I take limit as x tends to 0, limit x tends to 0, let me try to solve it. Limit x tends to 0. And now this is tan x into log x. Okay, so this, if I put 0, so this is 0 multiplied with minus infinity. So this is what I get. Again, if I put this is log x and this is cot x. So limit x tends to 0. So this is minus infinity by infinity. Now differentiating with respect to x, so I get 1 by x here. This is cot and this is minus cosecant square x. And now this is limit x tends to 0 by using L'Hopital rule here. Now I can write cosecant as a sine square x, and divided by x, and this is minus limit x tends to 0. Now if I take minus outside and sign and separate it, so I can write this as minus limit x tends to 0. So this is sin x by x and limit x tends to 0 and sin x. We know this is 1. So 1 and this is sin 0 is 0. So I will get 0 as a result. So thanks for listening, and do come back. I'll be trying to solve some more problems. Okay.